And then our other big experiment, this one's older. This one is Dave Tillman's biodiversity experiment, affectionately called Big Bio because it's like 10 acres big. This study is appearing now in college biology textbooks and also several high school bio textbooks too. And this was started in '94, and Dave Tillman just was like, you know what, I think there's something to biodiversity producing stability maybe in plant communities or something like that, but no one had ever studied it, and at the time scientists were like, you know, I just don't know. I don't think this biodiversity thing, I don't think it holds much merit. So Dave Tillman doesn't do things on a small scale. He does things on a big scale. So he took a 10 acre hayfield, basically cleared it of everything, made a big sandbox because we're in Anoka County, aka Anoka sandplain, and replanted it with all of these prairie species. And each of those plots has a different number of plant species, and he's testing the productivity of each plot based on how many species there are growing there. And you can see from that graph in the upper left-hand corner that number of plant species going from 0 to 16. What happens as your species go up? The productivity does what?
Goes up.
Yep, increases as well. Right. So this is another place that we visit, usually with most groups, because they want to see the big bio experiment. It's very visual. You're walking on these big boulevards with plants growing on either side of you. It's really a pretty place, especially when the lupin blooms in May.
You measure productivity in that by counting seeds, or how do you measure that?
Good point, because there's many different ways, isn't there? We discuss this with students. We discuss scientific design. How would you measure the productivity? Yeah, and they throw out all these ideas. He chose to do above ground plant biomass. So the field techs take a strip twice a summer with these like clippers with these jaws of death, they're electric, and they give it like a haircut through the middle. 3-meter long, like little pathway through the plot. Then they take all the biomass that's clipped, they sort it to species, dry it, and weigh it. And it's the compilation of all that data through all the years that gave us that graph there. And that's a regression, so that's from 2001 to 2005. We need to get a more recent graph. Anyway, in the lower left-hand corner there, this is also a big playground for other researchers. So in the lower left-hand corner, if global temperatures are going up, well, how is that going to affect plant diversity and productivity? So let's put out some heat lamps. Yeah, and that's what we did. We're basically baking the ground. The heat lamps heat up the ground. One of them heats it up 3 to 5 degrees C. Another one heats it up 1 to 2 degrees C. And we're going to see what happens. Okay, so that's out there. It's a very visual place. This is an old picture. Right now you see flashy things. You see rebar. You see flags. You see, oh, it's really cool. There's a lot going on. As far as programming goes, we focus more on the upper grades because we are also surrounded by some excellent nature centers. Wargo is one in particular. So, and because of the nature of our research, we decided we'd go for the upper grades. So we do 7 through 12, especially with the amazing standards in grade 7 and for high school biology. However, we have noticed the 5th grade, though, really fits in well with what we do. So we do 5th grade classes as well. Mainly they come from around the area, but we have been getting some from the Twin Cities as well. But they come to do ecology. This is Edison Senior High School, and these kids had never been out in the wilds before. They were always looking for bears, because I guess they'd watched Animal Planet. And it was raining, and they wore plastic bags. It was so amazing. They just didn't care. They're out there. And now they're doing light measurements with some vernier wear. They took light measurements in several ecosystems. We also do a lot of teacher professional development during the summer. Anybody from St. Paul Public Schools? Josh Leonard. Yeah, tell him he made the slideshow and or the PowerPoint. High school, and then we do the middle school workshops as well in the lower left. So that's Cedar Creek in a nutshell. Again, my contact information is on the information that's provided. We do not only school groups, but special interest groups, groups that just want to come out and see the research, that kind of thing.
How big a group can you take in a day?
You mean student-wise?
Yeah.
Yeah, we realize the need lately to go bigger and bigger. We have done as many as 150.
Okay.
That's big.
Mm-hmm.
75 to 90 is usually what we can accommodate easily to give each student the best experience possible. Mm-hmm. So we can talk later if you want.
Do you use volunteers to help Like, you divide them up into groups and use volunteers to help, or are they?
At this point,
Students?
I use field techs, yeah,
Okay.
students and grad students.
Mhm.
Yeah, so that everybody's qualified. Yeah.
How many months in advance do you schedule students?
About a month. Yeah, so you can wait and then go. You're here today to hear me yammer about climate change in Minnesota. Okay, now before we start though, I want to establish a baseline. And I'm going to follow a protocol introduced by Paige Keeley. Has anybody heard of her? Yeah. Okay, you know about her probes? Okay. Do you like her probes?
I haven't used them yet.
Okay, I love the probes. Yeah, and I'm not even a classroom teacher. When I heard her speak at MNSTA, she has books of these little questions that you ask your students to ascertain misconceptions in science that they are bringing to the classroom. And I love the idea because if you don't clear up those misconceptions, they're going to carry them from year to year to year to year. So Paige Keeley does not have any climate protocols, so we had to write our own. And this one's gone, the one I'm going to show you, is an example of what she produces for students, for you to use with your students. You can use them as a pre, like we're going to do right now. You can use it as a formative. As you're going along, you've just delivered the lecture of a lifetime. Did they get it? You know, you go, okay, who understands it? And they all go, uh-huh. You know, and you know that not everybody got it. You can give them a little probe and see where they are, or you can do it as a summative. So we're going to demo this one, and what I'd like you to do is just read the question, read the statement, and then figure out which student you most agree with. Now, thinking here, the goal here is to find out where your students are and if they have any misconceptions. Now, Paige Keeley is all about not embarrassing students because we know how they hate to be the one that is the odd man out, the outlier. So normally what I would do if we had more time is each of you would have a sticky note and you would write the name of the student you agreed with on the sticky note and then you'd pass them down and somebody would make a sticky bar graph on the board. So you wouldn't, if you were the only one that chose, I don't know, Jeremy, no one would know it was you, and they wouldn't go, oh yeah, you chose Jeremy, But we don't have the luxury of a lot of time today, so I'm going to ask you all to just raise your hands if you don't mind. Okay. Who agreed with Cassie? Who agreed with Will? Okay. I'm just going to do 16. Oops, that's Cassie. Okay, so 16 agree with Will. How about Jeremy? Sam? Okay. And you can also tell who was in class. Okay. Okay, 7 for Sam. So I'm just going to leave it at that and go, all right, so 16 kind of agree with Will, and 7 agree with Samantha. Okay. We'll revisit it at the end. So, I think it's safe to say that we all agree that climate is changing in some way. So yeah, what we're going to talk about today, remember, it can shift. The data, the information we're going to learn today or cover can be used either way, in a shift either way. So that's kind of fun. All right, welcome to Lake Superior here in Minnesota. But it's fun to remember that geologically we were like this at one time. I mean, we were closer to the equator a long time ago, but, So change, remember, change is what it's all about. So in Minnesota, our plant communities are all about the climate. Okay, the climate is really important here in Minnesota. Climate is the prevailing weather patterns over a period of time. And most often you'll find it's about a 40-year time period. I heard Don Shelby say this, but I think it was really attributed to some other meteorologist here in Minnesota. But weather is like CNN, and climate is like the History Channel. So that really helped me go, oh, yeah, that makes a lot of sense. Weather is now. CNN is now, in your face now. But you want to see what it's like over time? Okay, that's History Channel. Minnesota, we have that cold Canadian air mass looming up there. We've got the warm, moist air of the Gulf looming down there. we have what you can't see are these lovely light pink lines coming across like this, called the zonal flow. We know it as another name, don't we? That zone, that flow that goes from west to east. The jet stream, thank you. And as the jet stream moves across, it kind of can cause these air masses, bring, as the hook comes up and the Alberta clippers that we remember from the winter come down. Number one, where are they crossing more often than not? Yeah, we're like the bullseye for the intersection of these two air masses. And the reason the weather can change so extremely is when that jet stream is pushed down towards the south, what air mass are we feeling more of? The cold, right. And as the jet stream is pushed north, we feel more of that warm, moist air from the Gulf. So the climate is one thing, but the biomes can only live according to the climate regions that will suit them. So the climate, the biomes follow the climate. The biome, of course, is the large land area characterized by prevailing climate, all right? We all know that the biome is really a mosaic of, smaller pockets of different ecosystems, different plant communities, but predominantly this area is going to be coniferous boreal forest. Predominantly, this is the deciduous forest. Predominantly grasslands. Now look at Minnesota. We're the lower 48. We're the only state that has 3 major biomes within our borders. 3 major biomes. Now you could say, okay, but look at California. There's chaparral over there. They have 3. Okay, they do. But that's the only place you find chaparral, is on that little edge of California. I don't know if I would call it a major biome. And we can have 3 biomes because of our weather extremes. Okay, because of our climate extremes, excuse me. Our climates, okay. And what does that look like? Well, here we go. The 3 biomes. Okay, now, anybody have a problem with this because of what we just heard down there? Yeah, how many biomes do some say we have now?
With the 4 one, can I just say, Mary?
Yes.
If you haven't seen that, seriously, that was a new thing to you today. It's the top little corner, that little
Right.
bump up.
Right from Lake Itasca.
Yeah, it's just teeny little one, and not to...
I know, but would you...
But it's a newer version,
Yes.
and it is unique, but if you're still teaching 3 biomes, don't freak out, is what I'm trying to say.
That's good to hear you say that as a representative of the DNR.
Well, that's my educational perspective on it, from common sense, because
Yeah.
it's really particular, that 4th one, and there's a lot of overlap between the 2 other northern biomes. So
Right. And to its credit, going into Canada, it's a lot bigger.
yeah,
It just reaches down into us, that one little thing.
figure of it.
But yeah, at Cedar Creek, we have big debates about, like we have nothing else better to do. Let's debate the biome-ness of the tallgrass aspen parkland.
Don't freak out. It's great to introduce it, but
Yes. So the 3 major biomes, I guess we could say. Coniferous, deciduous, and then the prairie grasslands. We support 3 major biomes. So in other words, if the climate is changing and the biomes are dictated by the climate, we're like in a really unique area, aren't we? We're poised to put a positive spin on it. Bill McKibben, I heard him speak here, not here at the School of Environmental Studies, but he spoke 3 years ago, at the Institute. And he was like, as educators, you're really lucky to be on the world right now because we're going to see some major change. You're going to see science happening. You're going to see change happening. And I had never heard of it really put so positively. So here in Minnesota, the things that everyone's talking about, your students can actually see. So there you go, the silver lining. So the mantra of the day, where the climate goes, so goes the biomes. Where the climate goes, so goes the biomes. I'm seeing some smiles already. Okay. 3 things affect climate. 3 weather phenomena. We have temperature, which is simply a measure of the solar radiation coming into an area. Temperature is nothing more than a measure of the heat energy produced by the sun, provided by the sun. Then we have precipitation, not just the amount, but it's the timing. You all know that here in Minnesota we need a lot of winter snow because in the spring, when it melts, those spring plants need that moisture. If we have a super dry winter without a lot of snow, the spring plants will suffer. and you'll see changes. So it's not just the amount of rain an area gets, but it's the timing of that rain, okay? And together, those two affect soil moisture, which is a function of evapotranspiration. Love that word. Evaporation, moisture evaporating from the soil, transpiration, the movement of water from the roots up the xylem out through the stomata of the leaves. Okay, and that's a huge factor, as we'll go into later. So those three affect the plant communities that can live in an area. What does this look like? Okay, here's a nifty little diagram. Down here we have precipitation, dry to wet, hot to cold. So when it's wet and hot, we have tropical forest, temperatures get moderate a little bit, we have deciduous forest. Then they get a little cooler, but with moisture, we have pine spruce, and then we have a moist tundra. The reason you don't have a lot of trees with the tundra is because there's not enough solar radiation for photosynthesis to support large growth, but you can have small things. If the temperature is hot and dry, you'll have hot desert. Then as it moderates, you have a temperate desert towards a cool desert towards tundra. Now, could you put Minnesota on here somewhere? Yeah, what do we have? Tell my hand where to go.
Yeah, right there.
Right
Right here?
Yeah.
Will I go up a little bit to put in the pine spruce fir forest? Or
Right, and you put it all those.
So like right here, kind of?
Yeah.
Okay, yeah. Sorry for my lack of a pointer. My hand pointer. Yeah. Here's another way to look at it. Whittaker is this guy who in the 70s, now I don't know if he went around the world or if he just culled data from records. I like to think he went around the world, like in a balloon, and collected annual precip and average temperature from all around the world. And he developed this really nifty graph. The idea being that if you know the average temperature and average precipitation of any place, you can plug it on this graph and figure out what biome would be there. This is a very common graph. Just Google Whittaker biome diagram and it'll pop up. Again, same idea. When it's really super cold and not a lot of moisture, you get things like tundra. Up there is a lot of moisture, a lot of heat, tropical rainforest. Right in the middle, where things are kind of moderate, you get the temperate deciduous forest. Okay. Now, the three biomes that exist in Minnesota, they have ranges of tolerance. They have ranges that they can live in. The bulbs at the end are basically their extreme ranges. The area in the middle is where they thrive. Okay? Bulbs at the end are their limits, and then inside they can thrive. So if you kind of put all three of those together, they overlap. They overlap with 39 degrees for deciduous, but because that is its extreme end, we bumped it over one, so it was in its thrive range. And all three of those can basically survive at 41 degrees Fahrenheit. All three of those biomes can thrive at 41 degrees Fahrenheit. Okay, so that's the first number. And with precipitation, if we do the same thing, all three can thrive at what amount of precipitation? 26 inches. Okay, so we have 41 degrees Fahrenheit and 26 inches of precipitation. All three of those can kind of survive and thrive. Okay. Put that on the Whittaker diagram, and it kind of goes right there. Now we've converted them to, for those of you that don't instantaneously convert it to Celsius, I'm trying, but I'm not there yet. 5 degrees C is 41 Fahrenheit, and 66 centimeters translates to 26 inches. So it kind of puts you right there, and kind of in the taiga. Oh, everyone knows that taiga is also boreal, right? It is. I had to learn that when I came here, because all the kids were calling it taiga, and I'm like, what are you talking about? That's like tundra. No, taiga is boreal. It's like, oh, you're right. So yeah, taiga is the boreal. So that star kind of puts where Minnesota is, which makes sense. We've got taigas, forest, and grasslands. Now this one shows that on the North American continent, temperature isolines go from north to south. Northern part of our country gets less solar radiation. We can support communities like the boreal forest. Southern part, we get more solar radiation, different plant community, more like the deciduous. west of that line, you can see that it gets so much solar radiation that it's drier and we can support more of a desert. The line separating the two, where the boreal thrives, basically, and the deciduous can still exist, is 41F, okay? So that's kind of coming down the United States. Now, precip, on the other hand, goes from west to east as the weather patterns move, okay? So, again, 26 inches is that magic time when above 26 inches we can have these forest communities. Less than 26 inches of precip, you can see how the size and types of communities, everything's kind of stunted. It's more desertish, all right? And how does that affect evapotranspiration? Okay, just a quick primer. Evaporation again, movement of moisture from the soil. Evapotranspiration is that movement through the plants to the tune of a corn plant can average 2 liters of water a day. A sunflower, and I'm assuming this is a very large sunflower, about 5 liters a day. That's a lot of water. And then a large maple tree can transpire 200 liters a day. Think of all that water just going from the soil and out. If you can get your kids to visualize that, they will never look at a tree in the same way. They'll be like almost, it just is such a cool idea. Just think of the moisture just coming out. And again, that's a physical process. It's diffusion of water from higher concentration to lower concentration. Now I know they have their stomata and they can close that and all, you can get into all those issues too. But evapotranspiration is a huge part of our water budget. You can see, based on the mustard portion of that graph, how much of our soil moisture is, I'm not going to say lost. I guess you could say lost. Yeah, it's lost from the soil to the atmosphere, 67%. That's a huge number. Okay, so solar radiation and precipitation affect soil moisture because of evapotranspiration. All right, soil moisture on our continent, it's kind of a diagonal. We've had a straight up and down line. We've had a horizontal line. Now we're going to do the diagonal. Put the temp and the precip data together and you get this diagonal line. To the northeast of that line, we have less solar radiation but more precipitation. So cooler but moister. We can have those forests. Southwest of that line, we have less moisture but more solar radiation. So what kind of plant communities are you going to have? What's that?
I'd say it again.
Okay, you have less moisture, but more solar radiation. Deserts, yeah. And what do we have down there? Arizona, New Mexico, that kind of thing. Okay, so what does this look like when we put it on a biome level? Does that diagonal line work? Basically, yeah. It splits the grasslands, which can tolerate less moisture, more heat, from the boreal and the deciduous. With the exception of that little Kachinki thing there down by the bottom into Oklahoma and Texas. What is preventing that line from just going straight down and there being prairie in like Louisiana? Okay, the mountains are there, that's true. There's something else though that's causing, yeah, what's coming up from the Gulf of Mexico?
Moisture.
Yeah, a lot of moisture. Enough moisture to allow that deciduous forest to grow. Because they can tolerate heat, but they need moisture. So it's just that humidity generating machine that is the Gulf of Mexico. Okay, so otherwise, if we were a big square without the Gulf, that line would go diagonal probably. But we're not.
Those trees grow faster too, don't they?
Yes.
And ours up here first.
Yes, I would agree. Yeah, I would agree with that. I'm from Florida, and things grow pretty quickly.
Same species of tree, red pine, seems to be dramatic. It appears in the same. Somebody told me that plotted forest is planted the same year. It's dramatically different.
I would agree, while not having researched it myself, I would agree probably based on the fact there's more heat. Photosynthesis is heat dependent. The more heat you have, the faster things can grow. Yeah, I would agree.
Unless moisture is a constraint. Yeah.
Exactly.
Because I'm Texas, so.
Oh yeah, right now?
Oh, yeah, okay.
Then you have a longer growing season?
Yes, you do have a longer growing season. But yeah, moisture is key. Moisture is so important. So this again is just a quick graphic that shows everything that we've just reviewed. Over there, it shows how temperature. Blue is cooler than yellow. Bottom graph is precip. Blue is more moist than orange. Okay, so that goes like this, temperature goes like this. These are the biomes again. And this is soil moisture, the combination of the two. Moist towards drier. Except what's going on out here? Rainforest. Yeah, our temperate rainforest, right? The only part in our country with a temperate rainforest. Okay, now this would look really good if it was darker, but I'll tell you that this is 1890 to about now. And this is the Fort Snelling data, because they've been collecting data since before the turn of the 1900th century. And then this is precipitation. And what it's telling you is that right now in time, Minnesota's average temperature is 41 degrees F, and the average precip is 26 inches. It just so happens. It just so happens to be that way. Seriously. That's what it is right now. So, back to the Whittaker diagram. The U.S. is inside the blue triangle. The red star is Minnesota. A quick word on isolines. Those lines are fixed based on latitude and longitude lines. The numbers accorded them can change. Okay, does everybody get that? Okay. So this is 42 degrees now, but it can shift. It could either be like 39 or it can be 45, depending on what the climate is, what the temperature is at that area. All right? Precip lines the same way. In Minnesota right now, if the average temp is 41, that means the isoline that runs through the middle is going to be 41 degrees. Okay, you have that? All right. Precip, 26 inches. Same thing. The precip lines run down like this. So here's this line, runs through the middle, about right there. Where they intersect. Okay, get it? 41, 26, that's where all three biomes that's where they all meet. Remembering they each have a range, so that's not like the one point, but they all can exist right there. About Detroit Lakes, right now. That's right now. Okay, again, let's emphasize again, put a blue ring around it. It looks like that. Now that's today. What about in the past? This data right here, this one right here shows the global temperatures, and it shows that from 1980 to 2000 we've had a major, pitching. We've seen that one before. This one, 1890 to about 1980, gradual trend, but it was a trend. It was a static, it was a gradual trend. And then at 1980, both North and South Minnesota took a dramatic shift from the trend. Okay? Precipitation, basically between early part of the century and latter part, what are we seeing?
It's wetter.
Yeah, we're having an increase in precipitation. Okay. Back in 1930, average temperature in Minnesota was 40 degrees Fahrenheit, right here. Didn't mean to do that little. It was 40. Average rainfall was 22. So that means that middle isoline will now be 40. So that 41.26 point was south of where it is today, about St. Cloud. Is everybody getting me? Following it? So maybe not this. Darn. But maybe more like this. More of a Savannah-esque type idea. Up here, it's Bur Oak Savannah. Bur Oak trees interspersed with enough sunlight reaching the ground that we can have those tall grass. And for communities below, they do well in a dry, hot environment. But the thing is, we don't know what's going to be up there. Lee Freelick is a researcher at the U, and he does a great presentation where he talks about, and he's always so common sense, well, there's no analog for what's going to be happening here. We just don't know what is going to be growing. So, Park Service, DNR, they're already starting to think ahead and go, what do we want to grow here? If trees are going to be dying out, do we want to just let nature take her course and let perhaps invasives come in? Burn? Do we want to, do we want to plant things that we know will grow here and so we can develop our own kind of forest? Interesting ideas. Really interesting ideas. Anything to share on that? Do you know anything about
No, I think you put your finger on it. I mean, it is a very current debate about how to manage parklands, and I was referring a little bit to this earlier today too, when it's the mission of the National Park Service to preserve unimpaired the natural and historic objects within parks.
Yeah.
And all of which are, you know, subject to changes beyond the control of the Park Service, certainly. So then the question is, what should be done to mitigate, adapt, try to maintain
It's tough
habitats?
questions.
And there's no easy answer for that. No easy answer.
Because okay, we'll get into this, another talk about this. So what's going to happen? How's the change going to occur? If climate change is causing stress on our plant communities, a shout out to the Lord of the Rings, it'd be cool if they just kind of went and they just picked themselves up and left, because that means they could move themselves. But that's not how it's going to happen. We're going to pull in 3 processes that I think you teach. I'm not sure, is this covered in the high school curriculum? Or could you put it in? I suppose you could put it in. I haven't seen it in the standards per se. You're laughing and smiling. Okay. Succession, disturbance, and competition. As the trees are stressed by heat, by drought, and other things, they will become less resistant to invasion or attack by parasites, things like that, fire, for example. And as they die out, other things will come in and replace them. Folks up in the Boundary Waters will tell you they're already starting to see maples and some oak, yeah. And the birch are dying out. So that's how it's going to happen. It's going to be disturbance either by dying because of stress, or perhaps a fire comes through, or insects, or something like that. And then succession will come in and replace them with something else. And that's where we have to decide, what do we want it to be? Do we want to just let buckthorn come in? I don't know. Mark Davis at St. Thomas at McAllister says, well, we just have to get accustomed to this kind of thing. Or we can start planting what we want, what we know will survive in that range, and we can plant something new. Like we said, we don't know there's no precedent for this in history. We've never seen this before. So it's kind of an exciting time. And so that's how it's going to happen. And think about it, as these things die, and this is something I'm sure the Park Service and the DNR think about, as we do at Cedar Creek, as these trees are dying, they're falling, and they're fuel for fire. And it could create stronger fires, which then would have a greater disturbance. And, think about the blowdown, the July 4 blowdown. And I just, after talking to the first group, I want to go back and research, see what's growing there right now. Anything that they haven't seen before, perhaps. I don't know, I think it'd be interesting. So these are the 3 processes this is how the change is going to occur. Okay, so the boreal will slowly change. And that's it.